Hello everyone, welcome back to my channel. I am Bhagyashree, studying BE second year at Sri Venkateshwara College of Engineering, Bangalore. Today I am here with a new topic, test of significance of large samples in mathematics. Now let's see in this session. Introduction. Test of significance of large samples in mathematics. Importance of statistical testings in mathematics. Common statistical tests. Design, nature of variables, statistical test, statistic derived to independent groups, to related groups, more than two independent groups. Nature of variables, qualitative, quantitative. Statistical test is Chi-square test, student T test, Chi-square test, pair T test, Chi-square test, ANOVA. What is last sample? A last sample refers to a data set that contains a significant number of observations. It provides more reliable and accurate result for statistical analysis. Last samples help reduce the impact of random variations and increase the power of statistical test. Hypothesis testing in last samples. Hypothesis testing is a statistical method used to make inference about a population based on sample data. In large samples, hypothesis testing helps determine if a particular result is statistically significant. It helps the access whether an observed difference or relationship is due to chance or true effect. The null and alternative hypothesis. The null hypothesis states that there is no significant difference or relationship between variables. The alternative hypothesis suggests that there is a significant difference or relationship. In a large samples, hypothesis testing aims to reject the null hypothesis in favor of the alternative hypothesis. Now, the difference between null versus alternative hypothesis. Null hypothesis, alternative hypothesis. Null hypothesis is defined as H0, alternative hypothesis defined as HA. A statement about population parameter, alternative hypothesis. A statement that directly contradicts the null hypothesis. We test the likelihood of this statement being true in order to decide whether to accept or reject our alternative hypothesis. We determine whether or not to accept or reject this statement based on the likelihood of the null hypothesis being true. Can it include equal to, less than or equal to, greater than sign? Can include A not equal to, greater than or less than sign? T-test for large samples. The t-test is a statistical test used to determine if a sample mean differs significantly from a population mean. It is commonly used for large samples when the population standard deviation is unknown. The t-test calculates the t-score, which is then compared more critical value in the t-distribution. Pair sample test t-test, time 1, time 2. Assumption of the t-test. The data in the sample should be randomly and independently selected from the population. The population should follow a normal distribution. The sample size should be sufficiently large, typically n is greater than 30, for the central limit theorem to apply. P-value interpretation. The p-value is the probability of observing a test statistic as extreme as the one calculated, assuming the null hypothesis is true. If the p-value is less than the chosen significant level, the result is considered statistically significant. A smaller p-value indicates stronger evidence against the hypothesis. P-value approach assumes that the null hypothesis is true. The p-value is probability of observing the sample mean that is as or more extreme than observed. How to compute p-value to each of the type of test? Step 1. Compute the test statistic. Z0 equal to x bar mu naught divided by sigma divided by square root of n. Sample size determination. The required sample size for a significance test depends on the desired level of significance, effect size, and power. In a large samples, smaller effect size can be detected with high power. Sample size calculations ensure that the test has sufficient power to detect meaningful difference. Hypothesis test sample size calculations, factor which determine significant sample size. Sigma variation in process lower the variation, smaller is sample size. Sigma difference effect we desire to see. Alpha probability of type 1 error, considering HO false when it is true. Beta probability of type 2 error. Limitations of large sample testing. While large sample provide more reliable results, they can still be influenced by sampling errors and biases. The assumption of normality and independence may not hold in some cases. Large sample testing does not guarantee the absence of other confounding factors. Difference between large and small sample. Large sample. The sample size is greater than 30. Small sample. The sample size is 30 or less than 30. Large sample. The value of a statistic obtained from the sample can be taken as an estimate of the population parameter. Small sample. The value of that statistic obtained from the sample cannot be taken as an estimate of the population parameter. Large sample. Normal distribution is used for testing. Small sample. Sampling distribution like T, F, etc. are used for testing. Conclusion. The test of significance in large sample, a crucial tool in the mathematical analysis. It helps determine whether observed difference or relationships are statistically significant. Understanding the assumption and selecting appropriate statistical tests are essential for accurate and reliable results. Comparison of means of two samples. Just C equal to x1 minus x2. SE of x1 minus x2. S of x1 minus x2 equal to square root of SE1 square plus SE2 square. SC of x1 minus x2 equal to ST1 square divided by n1, ST2 square divided by n2 whole power to the half. Example, we have to compare and infer from the given data of that the R circumference of Indian and American children. Details. Number of subjects, American 625, Indian 625. Mean, American 20.5, Indian 15.5. Standard deviation, American 5.0, Indian 5.4. Thank you for watching.